Hi, good morning. Today we will see Buckingham's pi theorem applied to force convection heat transfer process. The number of variables involved in the force convection process are here. This is the number of numbers list. First one is the convective heat transfer coefficient H with the dimensions mt power minus theta, theta power minus 1, fluid velocity rho, fluid density rho, ml power minus 3, tube diameter or tube length will be there, d or l will be there, fluid velocity lt power minus 1, fluid viscosity ml power minus 1, t power minus 1, specific heat cp l square t power minus 2, theta power minus 1, k is ml t power minus theta minus 3, theta power minus 1. So h is called as dependent variable and all other variables are called as independent variables. So therefore we can write the relation between the variables will be h is a function of rho d mu velocity mu cp k. This is called as equation 1, or f of function of h rho d mu v velocity mu cp k is equal to 0 also. We can write like this also. Okay, now number of variables are 7 according to Buckingham's pi theorem. If number of variables are 7 and it contains fundamental dimensions m, l, t, theta, no, then m will becomes 4. Then according to Buckingham's pi theorem, number of pi terms can be written as n minus m, that is 7 minus 4, that is 3. 3 means you will get 3 pi terms, pi 1, pi 2, pi 3. So all these terms are dimensionless group, pi 1, pi 2, pi 3 are dimensionless groups or dimensionless numbers, we can say. So by considering pi 1, pi 2, pi 3, the equation will be transformed to a function of pi 1 comma pi 2 comma pi 3 is equal to 0, or we can write pi 1 is a function of pi 2 comma pi 3. Like this also we can write by considering the equation 1 can be transformed to equation 2 by considering all these pi terms, pi 1, pi 2, pi 3. So let us write the variables for pi 1, pi 2, pi 3. So pi 1, each pi term contains m variables, that is m is 4, 4 plus 1, that is 5 variables. So in which m variables will be repeating variables. So the repeating variables we selected here is rho, L, mu k will be repeating variables. So in all the terms rho L mu k will be there. So rho L mu k, rho L mu k, rho L mu k will be there. Rho L mu k, and remaining variable will be velocity v. So here A3, B3 and C3, D3 will be there. So now what we are doing is we are considering pi 1 term and apply dimensional homogeneity. So you will get pi 1 is equal to Nusselt number. So consider pi 2 term and apply dimensional homogeneity means we will get pi 2 is equal to Prandtl number. Consider pi 3 term and apply dimensional homogeneity means we will get this will be equal to Reynolds number. So therefore the equation 1 can be written as equation 1 can be written as equation 1 is there, no, h is a function of all other variables, or equation 2 can be written as Nusselt number is a function of Prandtl number and Reynolds number, or Reynolds number or Prandtl number. Like this we can write. This is the relation we are developing by using the dimensional analysis or Buckingham's pi theorem in case of force convection. So first we'll see the pi 1 term. So this will be pi 1 term. This is d dimensions of rho, dimensions of L. These are dimensions of mu. These are dimensions of k, and these dimensions of h. So first we equate the powers of m means you will get this equation m power a1 here plus c1 plus d1 plus 1. Now we equate the powers of L. Equate the powers of L means on both sides means you will get minus 3a1 plus b1 minus c1 plus d1. Similarly, equate the powers of t. Here now you will get this is t. You will get the powers of t will be minus c1. This is minus c1. This will be minus 3d1, and this will be minus 3 will be there. Equate the powers of theta means we will get minus d1, and this is minus 1. So from this we are finding the d1 value is equal to minus 1. Here now you will get c1 value is equal to 0. Here we will get now, once we know d1 is minus 1 and c1 is 0, now automatically we will get a1 is 0, and this value, from solving this equation you will get b1 is equal to 1. So by substituting all the values now you will get pi 1 is equal to HL by K you will get. Substituting the values. That means you will get now pi 1 is equal to rho power A1. That is rho power 0. Next one is L power B1. B1 is 1. Mu power C1. C1 is 0. K power minus 1. And this is H. So the pi 1 value will becomes now H and L by K. So this is called as Nusselt number. This is called as Nusselt number. HL by K is called as Nusselt number. Apply the same procedure for pi 2 term also. So let us consider pi 2 term and equate the powers. By equating the m powers, now you will get this equation a2 plus c2 plus d2. Equating the powers of L, now you will get this equation minus 3a2. This is minus 3a2 plus b2 minus c2, and this is plus d2 and plus 2 will be there. Like that, similarly equate the powers now minus c2 minus 3d2 minus 2 will be there. For theta, now equate the powers on both sides. Now you will get 0 is equal to this side 0. 0 is equal to this side. Now this is term minus d2, this is minus 1. So from this you will get d1 is equal to minus 1. From this you will get c1 is equal to 1. Substitute here, that is 1 and minus 1. This is 1 and this is minus 1. So you will get a2 is equal to 0. So from this equation you will get b2 is equal to 0 also. So by considering all these terms now, the pi 2 term will be rho power a2, L power b2, mu power c2, k power d2, and the value is Cp. Here it is, Cp is there. So if you substitute the powers now, you will find rho power a2 is there. Rho power a2 value is 0. L power b2 is 0. Mu power c2 is 1. And d power k power d2 is there, no, minus 1 into Cp. So that implies you will get pi 2 is equal to you will get mu Cp by k. So that is called as Prandtl number. In the same procedure, we are finding the pi 3 term also. So here pi 3 term is equal to rho power pi 3 is equal to rho power a3, L power b3, mu power c3, and next one is k power d3, and velocity will be there. So the dimensions of rho will be ml power minus 3, L will be L only. For mu will be ml power minus 1, t power minus 1 whole power c3. For k, no, ml t power minus 3, theta power minus 1. For velocity, no, lt power minus 1. So by equating the powers of m, no, so this side m power will be 0, 0 we have taken here. And this side, now you will get a3, this is a3 plus here it is there c3, and here it is d3 will be there. We will get this equation. Similarly, equating the powers of L, you will get this equation. Equate the powers of t, both sides you will get this equation. And equate the powers of theta. Theta, this is a theta, only one term is there, this side theta. So minus d3 is equal to 0. So from this, now by solving these equations, now we will get d3 is equal to 0 and c3 is equal to minus 1. And next one is this one, no? If you substitute here, you will get c3, this is minus 1 and this is 0, no? You will get a3 is equal to 1. And from this equation, now you will get, substitute all the values. The unknown value b3 is equal to found to be 1 will be there. So here now by substituting those values, rho power a3 is 1, b3 is now that is also 1, mu power minus 1, and next one is k power this is 0 into velocity. That means rho ul by rho vl by rho vl by mu will get. This is called as Reynolds number. So finally, now we will get the expression now. Equation 1 is there now. Equation 1, that is h is a function of all other variables. That is d rho mu k, d rho mu k, h c p k. So this equation will be h c p velocity will be there. This equation can be written as in terms of now pi 1 is a function of pi 2 comma pi 3. By considering the pi 3 terms, this is equation 2. So by considering pi 1 value is Nusselt number, is a function of, here it is pi 2 is Prandtl number, and this is pi 3 is Reynolds number we calculated. Or we can write now Nusselt number is a function of Prandtl number Reynolds number and Prandtl number. Like this we can write. So in force convection we can write Nusselt number is a function of Reynolds number and Prandtl number, or we can write Nusselt number is equal to function of Reynolds number power m and Prandtl number power n. So this value of C, the value of m, the value of n can be calculated by using experimentations on force convection, and finally we can develop the actual relation between all these non-dimensional numbers. In turn, the relation between the various variables in the force convection process. I hope you understand this concept. Thank you for watching this video. For more videos, you can subscribe my channel at at the rate of THPRESADS. You can search in the YouTube, or you can see while video no at this corner, at the bottom corner of the right side, no, you will get the this symbol. If you press this symbol, you will get the subscription button. You can subscribe my channel for more videos. Thank you once again for watching this video.